former Chancellor of MGM's Institute of Health Sciences, former Director of VJTI Mumbai, ex-Dean and Professor from IIT Bombay. Sir has completed his postdoctoral research work at the Department of Engineering Science Cryogenics Laboratory from the University of Oxford, UK. Honorable Professor Narayan Khedkar developed several technologies in the high-tech area of cryogenics and successfully transferred these technologies to LPSC and ISAC Bangalore. He is also actively involved in the review programs related to the development of cryogenics engine in the Department of Space. He has received many awards, and to name a few: Dr. P.K. Patavardhan Award, National Award, that's Professor A. Bose Memorial Lifetime Contribution Award. Honorable Professor Narayan Khedkar was elected as a Fellow of Indian National Academy of Engineering in 1988, a member of International Cryogenic Engineering Committee in 1994, President of Indian Cryogenics Council during 1993 to 1995, Vice Chairman at International Cryogenic Engineering Committee. We take great pleasure in inviting you, sir. We welcome you to MIT Art, Design and Technology University. May we please have a huge round of applause. Our sir is going to make a presentation on cryogenic innovations for energy storage and ultra-high speed rail transportation. Now I would like to hand over the mic to sir.
Good afternoon. I am seeing stomachs full and hall empty. Exactly different situation. Anyway, I'll make my talk interesting so that you don't feel sleepy. That's a challenge for both of us. So I'm talking about how cryogenics is going to play a role in energy and building future cities. It's a complete innovative idea, and it's a futuristic concept. So there is a lot of work which has been commenced already. And let's go through the slides so that we know how cryogenics is going to help us to build future cities. You have this mic. Cryogenics. Many people, including the engineering community, did not know what cryogenics is till the Department of Space started with the development of cryogenic engines, and there was a crisis because of the US government not allowing to transfer the technology of cryogenic engine to India. And that's why it became a big news. And you must be knowing that finally there was a MOU signed with USSR for import of cryogenic engines, not the technology. Although a few engines were imported, the whole technology had to be developed in-house. And that was the great success story as far as cryogenic engines are concerned. Cryogenics, what does it mean? It comes from the Greek word, as usual. Cryos means cold, and genos means to produce cold. Even we can say that this room is cryogenic, because it is cooler than outside, is it not? Can we say that it is cryogenic? No, it's air-conditioned. Then what does it mean? What does cryogenics mean? Simple definition doesn't tell us what cryogenics is. And that's the reason why we have to discuss what it comprises of. It comprises with production of very low temperatures and their effect on matter. Once again, very low temperature. Even the temperature in this room may be very low for some. It's a relative term. So we have to come to definition which can precisely say what cryogenics is. Generally referred to as the science and technology of producing a low temperature environment for applications. Once again, a vague definition. We can say that even this temperature is good enough for various applications, including human comfort. Cryogenics is a very interdisciplinary, consisting of essentially all engineering fields focused on low temperature technology. Once again, very vague. But here, the key word is interdisciplinary. It involves all the disciplines. Now comes the real definition. National Bureau of Standards, Colorado, defined cryogenics deals with temperatures below 123 Kelvin, 123 Kelvin. Because most of the conventional refrigerants will freeze out by that time. So we have to look for some new refrigerants which can help us to go below 123 degrees Kelvin. Refrigerants are vapors which go through change of phase when a refrigeration cycle is completed. Vaporizes, condenses, and so on. There was a question, if the refrigerants can change the phase, can the gases also go through the change of phase? And if so, can we get lower temperatures compared to the conventional refrigerants? And that was the question, and that was the beginning of cryogenic activity. Most of the refrigerants which are used in refrigeration applications do not satisfy the requirement of temperature below 123 K. So, the scientists, group of scientists, started working on this proposal, whether to liquefy the gas, if so, what methodology to be used, what processes to be used, and so on. And they failed. They could not liquefy. And they said that gases cannot be liquefied, and these are the permanent gases. The story ends. That's all, that's the conclusion by a set of scientists. And that's a written statement, published statement, presented in various conferences that gases cannot be liquefied. And if we have to go by the print words, we'll say that yes, nothing can be done. And that is where the engineering comes. We have to go beyond the print, beyond the conclusions drawn by others. We should have the ability to question these conclusions. And that's exactly has been done by the next set of scientists. They say that why? Why should we believe this conclusion? That gases are permanent. They cannot be liquefied. They started working. They looked at the processes the previous scientists followed. And that was very interesting to know that the work began in the direction of positive thinking, that gases can be liquefied. And then they said the processes followed by the earlier set of scientists was not proper. And hence, there is a need to revisit. And they said, if we use proper processes, proper thermodynamic principles, it is achievable. And that was a direction which was positive to go ahead with the research. The team of scientists demonstrated the following. These are very, very important for any engineer or any scientist. Don't blindly believe and pursue. don't give up. And as a result of this, we can see that they had to work very hard to prove that gases can be liquefied. And that's what all great persons do. And that's how they become famous. And of course, as I'm standing before you to talk about cryogenics, that means somebody has liquefied gases. And we are having temperatures below 123 K. So gases are not permanent gases. They can be liquefied to great cryogenic temperatures. And then starts the real liquefaction process. Something is wrong. Can you change? So, the scientists succeeded in liquefying the gases. The easiest gas to liquefy is air around us. You feel the air. You see what is the velocity with which it is moving. You can measure the temperature. But can you tell us at what temperature air will liquefy around us? Any idea, any guess? Since it is cryogenics, it has to be below 123 K. Yes or no? It has to be below 123 K. Then only we can say that the gases are giving us liquid which is having a normal boiling point, satisfying the cryogenic range. Some problem, I think. Huh. No. Okay, you are starting, move fast. Okay, 1877, Calitate produced fog of liquid air, and same time Pictet produced jet of liquid oxygen. So this is the beginning of cryogenics, where the temperatures below 123 K could be achieved. Next, please. The liquefaction temperature of gases is below 123 K. So they come in the cryogenic region. Next. Air liquefaction. We have so much of air available freely. So we can have liquefaction and use the liquid air for cryogenic temperatures. Commodity is freely available, but there is a process cost. And one can easily work out what is the Carnot efficiency for the temperatures which are given, then see what is the efficiency factor, and we work out what is the cost. And the working cost, the running cost for liquefaction is the major concern as far as liquid gases are concerned. Next. This gives a simple sketch where compressed air is first going through an aftercooler and then goes to the heat exchanger, and finally it is throttled and liquefied. The vapors go back to the heat exchanger so that the cold of that return gas is utilized. This is a very simple system which comprises of a compressor, aftercooler, a heat exchanger, and a JT valve. And with this, one can go for temperatures which are below 123 K. Next. One more sketch of the same illustration. Next. Next, please. Now, if you look at the nitrogen, the property, we are concerned with normal boiling point. Next, please. Next. Next. Some problem? Okay, I think let's forget about the PowerPoint. So the temperature is minus 196 degrees centigrade. Minus 196 degrees centigrade, which is about 77 degrees Kelvin. That is the temperature, normal boiling point of nitrogen. Now, if this is the level of temperature, we can definitely use for variety of applications at low temperature. But what I am going to talk today is how to use these liquids as a energy storage. Why energy storage? Because whenever you are using non-conventional sources of energy, they are not available 24 hours. For example, solar energy. Available only in the daytime, nighttime it's not available. Wind energy is not available for all the 24 hours. Intermittent, whenever we want to supplement the energy, one can make use of the liquefaction for supplementing this energy. These are some other gases, and the normal boiling point of helium is the lowest, 4.2 degrees Kelvin. Can you imagine? Minus 269 degrees centigrade. Next, please. Then, having succeeded, they started producing the plants, liquid nitrogen plants, liquid oxygen plants, for supply of these cryogens. Next. Next. This dates back to 1899 to 1902, when the concept started that it is possible to store energy using the liquefaction of gases. LAES, liquefied air energy storage. When we are liquefying the air, for liquefaction there is energy put into the system, and that is the energy which is available to reuse whenever we want. Next. 1977, the concept first proposed by researchers at University of Newcastle upon Tyne, UK, and between 2009 to 2012, that is the period when an industry has taken over and built the prototypes to show that this concept of energy storage is feasible. Next. So this gives a simple block diagram to illustrate how the liquefaction takes place and how the liquid air is used for giving back the power. Next, please. The processes which are involved are charging process, storing process, and discharging process. This can be shown in this block diagram, where one can see there is a power input to the compressor, which compresses the gas so that it can be throttled or expanded for liquefaction purpose. And then there are three storages: hot thermal storage, so that that can be used for heating applications; cryogenic energy storage, which can be used intermittently whenever energy is required; and other is high-grade cold energy, which can be used for regeneration purpose. Next. So LAES, this storage of liquid air, uses off-peak power to compress, cool, and liquefy air. Whenever power requirement is not much, that power is diverted for liquefaction. Liquid air is stored in insulated tanks, minus 196 degrees centigrade. If the insulation is not proper, it will boil off, and all our energy will be wasted. So it has to be preserved in well-insulated, which are super-insulated vessels for storage of such cryogens. And then, whenever power is required, liquid air is converted into vapor, compressed, and that will run a turbine to generate energy. Next. So this is a typical storage system. You can see the capacities. One advantage of liquid storage is the ratio is about 800. 1 meter cube of gas, if you take, it becomes 1 upon 800 times liters or meter cube liquid. So you get the volume advantage, and that's how storage becomes simpler. But they should be well insulated, preferably super insulated. Next. Of course, any system will work if economics permits, if it is affordable. Otherwise, no technology can take off. Next. This, just click. This gives an illustration of the entire prototype plant, how it looks like, what are the components. Click on that. होत नहीं का? ठीक है, okay. So next, take it. 5 megawatt plant. This is the one which is in Manchester, can power up to 5,000 homes for around 3 hours. So this is the capacity which is available from the cryogenic energy storage plant, which has a capacity of 5 megawatts. Next. Now I come to the next part of the application, and that is levitation. So as we are going for lower and lower temperatures, people were not satisfied with the temperatures which are available from liquid air, liquid nitrogen, and liquid oxygen. There was a craze for lower and lower temperatures. 77 K was considered as high temperature. Then they started looking for other gases like hydrogen. That came to a level of 20 degrees Kelvin. So liquefied hydrogen. Having liquefied hydrogen, there was a still further craze for lower temperatures. Then why not liquefy helium? And that is how the entire exercise of going lower and lower in temperatures began. Next. This was first liquefied on July 10, 1908 in Leiden, Holland. This was by a scientist known as Kamerlingh Onnes. You can imagine, without any thermophysical properties available, without proper instrumentation available for measuring such temperatures, without proper equipment available to liquefy helium, which can go up to 4.2 K, must be a great challenge. And today, if you go and ask the operators of liquid helium plants, they say that even operating liquid helium plant is most difficult. Operating, not building, not developing. And one has to start from scratch and develop this technology of going down up to 4.2 K. Next. This is one of the plants. Okay, next. Now, experiments conducted under Maglev, back. Anki mage. Experiments conducted under directions of Onnes, who liquefied helium. They discovered superconductivity in 1911. When was it liquefied? 1908. When the superconductivity was discovered? 1911, in 3 years' time. The moment you have some achievement, see how it can be applied. And superconductivity was discovered in 1911. That metal can become superconducting at low temperatures. That is the biggest, I should say, invention, not a discovery. And having done this, what are the applications of superconductivity? Next. Onnes, the discoverer of superconductivity, said, the fact that a pure metal can be brought to such condition that its electrical resistance becomes zero is certainly of itself of highest importance. So that was the conclusion by the discoverer of superconductivity, Kamerlingh Onnes. Next. Then the application started. One of the applications is Maglev, superconducting magnetic levitation. Next. Maglev trains are extremely environment friendly because they use only electricity. Secondly, maglev trains also reduce noise pollution because there is no friction. The whole principle is the rails and the wheels of the train do not touch each other. The train is completely floating. And that's how sometimes it is said, these are the flying trains, not running trains. It flies. There is absolutely no friction. Next. April 2004, first high-speed maglev train in Shanghai, China. 30.5 kilometers from Pudong district of Shanghai to Shanghai Pudong International Airport. This is the achievement, but this is not superconducting. It's conducting. Next. A team led by Dr. Deng Xiang at Southwest Jiantang University in China, they have built the maglev trains which can go up to the speed of 2,900 kilometers per hour. 2,900 kilometers per hour, even the aeroplanes cannot beat. Vacuum is used to minimize air resistance because as the velocity goes up, air resistance becomes a bottleneck. And if there is a vacuum surrounding the train, there is no resistance. But look at the cost involved. Nothing is coming free. As you go for better and better performance, you have to put in more and more infrastructure. And that cost, it becomes sometimes prohibitive to make it practical. Next. The current fastest passenger carrying maglev train can travel up to 431 kilometers per hour and reach 501 kilometers per hour. That is the speed, which is an example one can see in China as well as in Germany. Next. When we are talking about use of helium for superconductivity, use of liquid nitrogen or liquid air for cryogenic energy storage, one has to see that whatever boil-off is taking place because of heat input to the vessels, that will lead to loss of cryogens. And to prevent that, one can have the closed cycle cryocoolers to recondense the vapors so that there is absolutely no loss. And this was a massive program of cryocooler development taken up by IIT Bombay, still going on. So we have built coolers which can go up to temperatures of 10 degrees Kelvin. That is the temperature which is achieved. And these cold tips can be used in the cryogenic vessels to liquefy back the vapors generated. And that is an achievement, and that is the reason today, if you go for MRI, earlier they used to have a big liquid helium plant. And the cost of MRI was very exorbitant. But today it has become very affordable. Why? Because they no longer use liquid helium plant. They use cryocoolers. And that's how there is a cost reduction. So every effort which the scientists and engineers are putting in is towards the help towards the mankind. Today, you don't go for simple X-rays, you go for MRI because it is affordable. Why it is affordable? Because of cryocoolers. Next. The coupling of cryocooler, heat exchanger, and storage tank technologies has led to the ability to store cryogens nearly indefinitely using zero boil-off. Otherwise, if you leave liquid nitrogen in a vessel, after about 2 months, you'll find that there is nothing left. Everything is evaporated. Because there is no insulation available which will stop the heat leakage. Liquid nitrogen at minus 196, ambient is at 30 degrees centigrade. Bound to be heat conduction, heat radiation, heat convection, and so on. And to stop that, one can use the cryocooler so that absolutely there is no vapor loss. Next. Necessity is the mother of inventions. There was a necessity that how to prevent the boil-off, and cryocooler becomes handy. Next. At the same time, finding application to the invention is the mother of creation for necessity. Because you have invented something, but you have to also find the applications. Next. Again, so nothing surprising if magnet falls down. But if we cool this vessel by liquid nitrogen, it becomes superconducting. And then, if you drop the magnet, it will not go to the bottom. It will just float. Very interesting to see, but anyway. So this is the levitation. Because the magnet is opposed by the electromagnet below, and because of that, the magnetic flux will not penetrate through the vessel, and it will act like a spring, pushing the magnet up, and it simply floats. And this is the basic principle which is used in the test train, which runs on cryogenic superconducting levitation train built in Japan. It runs between Tokyo and Okasa, and at an amazing speed of about 500 kilometers per hour. And that is the great achievement. So if we can succeed in getting high temperature superconductors, you must be aware that a lot of work is going on high temperature superconductors, which can superconduct at liquid nitrogen temperature or even higher temperatures, then the cost of infrastructure reduces. And such principles become viable. So one should not get discouraged by today's cost, because we keep on seeing that technology evolves, materials evolve around it, and things happen. And that is what is the hope, that for the theme of this today's conference, future cities will have cryogenic energy storage as well as the trains running on superconductivity at amazing speeds. Thank you very much.
Hello. If you have any questions, you can ask those questions to sir. Maybe we can take one or two questions. Yes.
Narayan sir, it's a very interesting and intelligent task. I have a very small question. That 1911 superconductivity was invented, and it is 2019. We could not come up liquid nitrogen. Like it started from liquid helium and moved to liquid nitrogen. But then after liquid nitrogen, there are no breakthroughs.
Yes. I think you are aware that there was a period around 2000. That was the superconducting era. Every lab having the low temperature section was busy in developing high temperature superconductors. And I was told even Japan, scientists never went home. They were sleeping in the night in the labs itself. So much hard work was done. And they succeeded in making the superconductors which can become superconductors at liquid nitrogen temperatures, even higher. But the main problem was to draw the wire out of it. Because finally, we had to wind the wire, electromagnet. And that was the main catch. The materials are developed. You can see the literature. And even C.N.R. Rao, who was then director of IISc Bangalore, once he was giving a lecture in IIT Bombay on superconductivity. He said that we are all working. All the scientists, all the engineers are busy in developing these superconductors. But tomorrow, don't get astonished if my lab assistant or a class 4 comes up with a phenomenon of superconducting material. Because ITC, yeah. So that's what he was saying, that it is not necessary that one should be engineer or scientist to develop something. Any person can develop. So let's still hope that we can draw the wires. As nanotechnology has helped, the wire technology will help us to go further. Thank you.
Thank you, sir. Any other question? Okay, sir, before you take a leave, I would, sir. Let's proceed. Now we have the next presentation by Honorable Dr. Y.C. Sharma, a professor from IIT BHU Varanasi. Sir has a vast experience in various areas. For example, renewable energy and biofuels, development and characterization of heterogeneous catalyst, river health science, monitoring of river Ganga. And his achievements include Fellow Biotech Research Society of India in 2017, Hayoshi Environmental Award in 2016, Fellow of Royal Society of Chemistry in 2014, Principal Investigator in Trilateral Project on Biofuels, DST Government of India 2014, IST Award for carrying out best research by young teachers in 1997, SCRC Visiting Fellowship in 1997, Editor-in-Chief of International Journal of Pollution and Solutions in USA. He is also an editorial board of member of journals, Journal of Applied Sciences in Environmental Sanitation. He was listed on the panel of reviewers of more than 50 international and national journals, including the journals from Royal Society of Chemistry, American Chemical Society, Elsevier Taylor and Francis Ville, etc. He has more than 148 publications in the last 5 years. Now let's welcome sir with a round of applause.
Thank you very much. I'd like to thank the organizers of conference who gave me this opportunity to share whatever I'm doing in my laboratory. It's a conference. I thank them again. So, if we look at the global scenario, and if we look at the problems which the countries are facing today, we find that population sits in the center of everything. The British Register suggests that the first doubling of world population occurred in 1500 years. Second doubling of global population was reported in another 150 years, and third doubling was reported in another 15 years. After that, data on population growth, as far British Gazetteer is concerned, is not available. It may be because countries started census officially, and then the population scenario of each of the countries is known to us now. The talk of my talk today is around synthesis and application of biofuels, opportunities and challenges. Because if we look at the minimum requirements for sustenance, we find that we should have food, we should have shelter, we should have clothes. Everything is driven from the same land area, but population increases. Morning's author at the Nobel laureate, he suggested, he displayed that 2020 population would be much, whatever is there would be much higher. And then what can be done? How does population be sustained? How food, shelter or clothes should be there? How can industries be run? So we find several things. We can go for industries. We go for agriculture. But the land area is limited. We require energy for each and every aspect, each and every purpose of our life. If it is very hot, we require air conditioners. If it is cold, we require hot blowers. So focus goes on energy all the time. When it is energy, if we look back at the scenario which is available with us, we find that in 40s, America used to have the best wind energy farms. But then after application of fossil fuels, coal especially, the per watt generation of energy was per watt generation, kilowatt generation of energy from coal was much cheaper than that of wind energy. So coal came into existence, and then when coal came into existence, problems also came into existence. Better quality coal has already been excavated. If we look at the research areas today, that one of the important research areas is that application of low-grade coals, because we have already utilized the best grade coals. Then what is the solution? Superconductivity? Probably not. Until it comes at normal temperature, high TC we call, it's of no use. Nuclear energy, probably yes. But then there are a few countries of the world which use nuclear energy as their energy sustenance. We don't have fuel, we cannot survive on nuclear energy, but that is probably one of the solutions. Then what is the solution? Probably the biofuel can give us the solution. Biofuel. If you look at our country, it is largely agriculture-oriented country. If you look at the fuel which is available, which we are using, we have all these sources. The data says that largest consumer, we are the largest consumer after US and China, third largest importer of crude oil, produce only 0.9% of world oil and consume 4.5% of world oil demand. Consumption of oil in India grew 8.1% compared to world growth of 1.9% in 2015. Biofuels, let us see how can we utilize them. Biofuels are solid, liquid or gaseous. This is how biofuels are coming into the application. Biomass to biofuel. We have plenty of biomass available, which is largely wasted. If we look at the scenario of a few months back, it was in discussion, burning of the cellulosic, that is leftover cellulosic biomass that can be utilized using different simple processes. Biofuel production pathways, these are well-known pathways. It is not working. Well-known pathways of biofuel production. We can have a feedstock Feedstock could be sugarcane, corn grain, or any cellulosic biomass. It could be agriculture residue, which was burnt, which is rather each year, which is burnt just like that. We can have algae also, but then how we can use that, I'll discuss in the slides. By using biofuel, we can have energy security, we can have these problems which are there, but then there are solutions as well. We can develop rural economy, because if we go for biofuel production, if we go for growing those feedstock materials, those have to be there in rural areas, and we can provide them. We can provide them jobs. These are a few examples of well-known biofuels. Cow dung cake is known to all of us. Sawdust, which is used in different purposes, is also used as biofuel. Biomass briquettes are not that common, but are well-known biofuels. Feedstock for biofuel production are basically food crops, non-food crops, lignocellulosic biomass, agro-industrial residues, and single-cell organisms. These are examples of these well-known feedstock materials for biofuel production. We can have gasification, pyrolysis, or hydrolysis as the well-known processes for biofuel production. We have different generations of biofuels. Some of you might be knowing. Generation 1 biofuel, Generation 2, Generation 3, and currently Generation 4 biofuels are available. Generation 1 are derived from food crops. Generation 2 are from non-food crops, because food crops, if we look at our population, and there are several other countries also which have larger population, they have a problem of food grains, like they do not have enough food grains for their people, so they import it from other countries. So use of Generation 1 biofuels is not feasible in a larger economy like ours. Generation 2 biofuels, like production from non-food crops or lignocellulosic biomass or biochemical and thermochemical methods. Generation 3 derived from algae and other materials. Generation 4 is further extension of these materials. Potential biofuel avenues from algal feedstock. We can use algae also. Algae, microalgae, which is rich in lipids, can also be used for biofuel production. This is a bit debatable, which I'll be discussing in the slides to come. Resources in algal biodiesel. Biodiesel is one of the biofuels that also I have covered in a few slides. Autotrophic microalgal production, like algae has to be produced, and then through application of a few well-known chemical methods, the lipid content can be enhanced and then can be harvested, and then finally biomass can be obtained, and then lipid can be extracted from that, and that lipid can be used for biofuel production. This is a debatable slide, energy, return on energy investment for algal biofuels. It is quite in favor of production of algal biofuels. We go for pretreatment of the material, physical, chemical, thermophysical methods, thermochemical methods, and biological methods, and then finally go for further processing, and then small chemistry is involved there. Butanolic fermentation for production of butanol and biobutanol. Biomethanol is one of the hot cakes these days through which we can produce biomethanol, and then maybe that we can, in future, we find biomethanol economy in our country. We can have biobutanol also as one of the biofuels. Biobutanol has some problems that its production is quite less. Its amount which is produced in lab is less, and then it has to be scaled up because it is very much successful in laboratory. It can be scaled up using a few methods and then can be utilized at pilot scale and at industry as well. Production of biodiesel. We can have oil crops, we can have seeds, crude vegetable oils, and then we can have biodiesel by using a simple method of transesterification. This is a US biodiesel consumption, like it's quite mature in area these days, in our country also. These are different countries which have already done a lot of work on biodiesel production. If we look at our country, we are far behind. Because if we talk about biodiesel, what we require is a feedstock material. The process is well known. There are several processes, but transesterification is one of the simplest process, simple to control, and through which we can have better quality biodiesel. But then feedstock material is a problem. First generation, we saw like edible oils, we can produce biodiesel. Anything which can give us lipids can produce biodiesel. But then feedstock is not there. Feedstock is less. There is a problem. But then there is one of the feedstocks, that is waste frying oil, waste cooking oil. Concept of waste cooking oil in our country is coming up gradually, and maybe that in time to come we have enough waste cooking oil and that can be easily converted into biodiesel. We already have our biodiesel policy, biofuel policy 2012, where India has to use B20 by 2020. So, but then it's a problem of getting that much of amount of biodiesel. Till now, only Rajdhani expresses run on B20. Why other trains are not running? Because we do not have enough quantity of biodiesel produced at the moment because of limited amount of feedstock material. This is very important fuel. It contributes to reduction of greenhouse gas emissions. It contributes to security of energy supply, promotes a greater use of renewable energy. But then there are a few restrictions which we discuss right now. Biomass to biogas. We can use biomass to produce biogas as well. There are well-known processes. Comparison of fuel properties of petrol and bioalcohols. Like if we take even biodiesel, we find that their characteristics are almost similar. Energy density is quite compatible with the fuels which we are already using. Bioethanol, and then gasoline, which we are already using. Main fuel properties of diesel and biodiesel. we find that are quite all right. They are quite in a particular range and can be replaced. If we can replace the engines, we can replace this, but then in replacing engines is very difficult. B20, we can use the same IC engine which is already working. Greenhouse gas balance, it is like you take any of the biofuels, we have this greenhouse gas balance, better as compared with the other fuels which you are already using. If you use biodiesel, this is a comparison that how these emissions are reduced. Alternative fuels for internal combustion engines. These are several fuels which are already available, and then we can use blends of biodiesel if we talk of, or bioethanol also. There's simple chemistry involved here. As far production of biodiesel is concerned, we take any lipid, we take any of the feedstock. That is, it could be a first generation, second generation feedstock material, or it could be simply that algal oil. And then we take methanol, and trans-esterification takes place, and we get biodiesel. Biodiesel is methyl ester, fatty acid methyl esters. And then what else we get? What else we get is a very important byproduct, glycerol. If you look at the research which is going on these days, after trans-esterification, that is synthesis of biodiesel, is basically production of valuable materials from byproducts of biodiesel. That is also one of the important areas, but then it is not focus of the talk of today. These are other details of trans-esterification which we use for biodiesel synthesis. Thermochemical conversions can be used for breakdown of solid biomass. Thermochemical conversions are well known: combustion, gasification, pyrolysis, liquefaction, and other materials. Comparison of these processes are already well known. And then using all these methods, we can derive biofuels using cellulosic biomass. Chemical reactions involved in gasification. We get drying, pyrolysis. We get fuel, we get other materials. One of the important materials which we draw from the techniques is biochar, which is once again a very important material which can be used for environmental remediation as well. We get downstream processing of the process of the products which we produce. Pyrolysis and hydrothermal liquefaction of production of bio oil. These are well-known processes. Hydrothermal liquefaction of gasification of biomass. We get fuels as final products. These are feedstock materials. A simple sketch of the reactors which are used there for the process. These are some different applications of biofuels. Algal biorefinery, they are like, we do not have a lot of expertise. We do not have a lot of agriculture, a lot of farms where we can have a larger amount of microalgae. But then I work in some collaboration with a few groups outside. They have huge farms where they, like 75,000 liters capacity raceway pond for cultivation of microalgae, and from which they get enough amount of biomass. Like in our laboratory, we have 150 liters of capacity of vertical reactors for cultivation of microalgae, and we get very small amount of biomass from which we can draw few ml of algae oil. But then that is feasible. That shows the feasibility. If we can have larger raceway ponds, we can have larger amount of biomass and can produce algal oil, which can again be used for biodiesel production. We have liquid fuels, bioelectricity, steam generation, and then at center is lignocellulosic biomass. We have chemical commodities, bio-based materials, and then we have all environmental protection, waste management, energy and food supply, and then employment as well if we use these processes. Waste to energy. There are several waste materials which are produced, and then it's not a very new concept. Waste can also be converted into energy, and that will automatically solve the problem of waste generation and waste management. Bioeconomy scheme. These are several applications. Transportation, power, and heat. All of you might be knowing that very recently there was it was for an experiment only, that in August 2018, this flight of SpiceJet took place from Dehradun to New Delhi. That was the fuel which they used was blended with biodiesel. But then question once again comes that much of amount of biodiesel produce must be there. If it is there, solution is already available with us. We have this National Policy of Biofuels 2018, where we make some claims. We plan that biofuels must be strengthened, and then maybe we have possible solutions for energy scarcity in our country. These are recent episodes are known to all of us. This is lignocellulosic biomass, which is burnt just like that, and which itself creates environmental problems. The problem of fog and smog in New Delhi, that can be converted into valuable biofuel. That is ethanol, bioethanol. This is already, the process is already known. This is potential of, state-wise potential of cellulosic biomass which is available in different states of our country. If the process is employed that this way, that way, that directly helps our country. We have a lot of potential of lignocellulosic biomass, especially the states of Uttar Pradesh, Punjab, Maharashtra, Gujarat, where we have agriculture as one of the important sectors. These are several sources which we all know. Bioenergy. These are several sources of biomass: industrial residues, animal residues, municipal solid waste. Coal, petroleum, and natural gas. These are not biomass, all of us know. They have significant potential. Modern biomass, traditional uses of biomass, fuel wood, that is not at all very much economically viable. If that is used for biofuel production, That serves a lot of purpose of our economy. These are different details of bioenergy. Modern biomass, carbon capture, it helps in, it is carbon neutral. Biodiesel, biofuels, bioethanol, these are carbon neutral. Carbon positive biomass, carbon positive fuels, whatever we are using are carbon positive. There is a lot of generation of carbon dioxide. Renewable energy consumption in major markets in 2017 and projections for 2023 for 5 major markets. And proportion of renewables in overall energy mix. Total final global energy consumption from renewables 2013. We have 50% modern sources. We have small percentage from other renewables, 4% from solar photovoltaic cells. That market is coming up. Total final global energy consumption from renewables in 2017 is a graphical representation. Leading countries based on biofuel production, 2018, United States is maximum, Brazil. India is also there, but India is contributing very less amount of the global biofuel production. Biofuel, primary, secondary biofuels. Advanced generation of biofuels, first generation, second generation. Vegetable oils and residual oils and fats. We can have biodiesel, sugar or starch. We go for fermentation, we go for bioethanol. If we take some of the materials, wood or some other products, we get biomethanol as well, which is quite important, and then a lot of work is going on in this particular area. This is how the process goes on for production of biofuel. It is probably an alternative. Biodiesel seems to be an alternative. If we look at the research, part of biodiesel, we have to have a feedstock, we have to have a catalyst material. If I understand whatever I have done so far, the research element which is left probably in case of biodiesel is on synthesis of efficient heterogeneous catalysts. Because feedstock is already known. If we change the feedstock, you characterize the feedstock, we can understand what is going to happen with the production amount. Disadvantages, very less, but then if we cannot afford taking first generation feedstock that is not at all used now. That can be used where this feedstock material is available in plenty, but it's very expensive. We talk of the edible oils. We have increased oxides of nitrogen, but then it's as compared with the regular fuel which we are using, this is very less negligible. These are aromatic bioethanol, reduces greenhouse emissions, carbon neutral, renewable, biodegradable. These are a few disadvantages of bioethanol. It requires significant energy and large amount of land. Fuels with more than 10% ethanol content are not compatible with non-E85 ready fuel system. It can negatively affect electric fuel pumps. It is not compatible with capacitors fuel level gauging indicators and may result in erroneous fuel quantity indications in vehicles. Biogas, large amount of methane gas. free-flowing thick sludge formation which can be used as fertilizer, sanitary way of human and animal waste disposal, conservation of wood. Disadvantages of biogas, many times there are explosions, high capital cost is involved, incorrect handling of liquid sludge results in pollution, needs proper conditioning. Use of fuel requires removal of carbon dioxide and H2S, which is impurity and which is quite corrosive as well. We have these feedstock materials, plant biomass, lignocellulosic biomass residues, which can comfortably be used for production of biodiesel, convert the lignocellulosic biomass, ethanol, and utilization of intermediate products. Yes, please. Biomass to electricity. If we take algae, we produce good quality, good grade biodiesel. There are few barriers. And then if we talk of feedstock material, we find at the moment, we find waste cooking oil as probably the most potent feedstock material because it has to be used. Population will increase. It has to be available in larger amounts, and then that can comfortably used for generation of biodiesel. So, thank you very much.
Thank you, sir. Thank you very much. May I request Dr. Rajneesh Kaur Sajdev ma'am to kindly felicitate sir. Honorable Dr. Y.C. Sharma. Thank you, sir. Thank you, ma'am. We are going to have now track-wise parallel sessions at two different venues. Energy and management will be conducted in this particular hall itself. It's not going to be there in Swami Vivekananda Seminar Hall, so please don't go there. Whereas city and buildings of the future will be in APJ Abdul Kalam Seminar Hall, 4th floor at SFT. Factories of the future will be in Sir Vishweshwaraya Seminar Hall on the 3rd floor, whereas waste management will be in C.V. Raman Seminar Hall, 3rd floor of SFT. So we'll quickly have a tea break and make sure that you come back. And once you're done with all these sessions, in the evening we are going to have a cultural program and gala dinner. So cultural program will be here in this particular hall itself, whereas gala dinner will be next to Design, IOD, Institute of Design. So make sure that you make yourselves available. Whereas tomorrow, please reach the auditorium sharp at 9:15. Thank you.
Good evening, everyone. I am Cadet Binayak Kumar Singh from Maharashtra Academy of Naval Education and Training, and the topic of my presentation is energy from waste. First, the contents of my topic is introduction of waste to energy, definition of waste, types of waste, waste hierarchy, energy recovery technology from waste, and conclusion. As rightly said by the Nobel Peace Laureate and Bharat Ratna awarded Mother Teresa, I only feel angry when I see waste, when I see people throwing away things we could use. C is right. Why there is a need to throw waste when we can use it, recycle it, and nowadays we can even produce energy from it. Every day when I wake up in morning, there is a thought came in my mind. Why there is a need to think to manage waste, and why there is a need to search some resources which are going to provide energy in current scenario. The main reason behind this is that, as we all know, that our natural resources are depleting day by day. According to the recent research and publication of Review of the World Energy, oil and gas resources are going to last for only 40 and 55 years, and the coal is going to last for only 200 years. The second main reason behind this is barren lands required to dump this waste are very limited. In 2018, India produces 62 million tons of waste, and land required to dump is 1240 hectares. So it is estimated that India will going to produce more waste in coming years. It is estimated that by 2031, India will going to produce 165 million tons of waste by 2030 and 436 million tons of waste by 2050. And the land required to dump this waste are 66,000 hectares per annum. So we need some technology to manage this waste, and the solution of all our problems is production of energy through waste. What is the waste to energy conversion? Waste to energy conversion is a technology through which we can produce waste in the form of electricity and heat from the primary treatment of waste. The efficiency of the waste to energy process is 40%, and we will reduce the volume of the waste by 90%. First of all, we will see what is waste. Waste is unwanted or unusable material which is discarded after primary use or worthless, defective, and of no use. Waste can be anything. There is types of waste according to their production: waste from urban areas, waste from industry, waste from biomass, and waste from biomedicals. Waste hierarchy. Waste hierarchy is a tool which helps in evaluating processes that protect the environment alongside resources. Main aims of waste hierarchy are minimize the generation of waste, minimize the recovery and reuse of waste, minimize the amount of waste that goes to landfills. 5R technology of waste management are refuse, reuse, reduce, reuse, repair, and recycle. Now I will going to illustrate the processes which can help us to produce energy from waste. The first process is incineration, second one is pyrolysis, third one is gasification, and fourth one is plasma gasification, and fifth is anaerobic digestion. Incineration. Incineration is a thermochemical process in which the waste is treated in the temperature of 900 to 950 degrees Celsius in the presence of oxygen and release heat. Electrical efficiency of this process is 18 to 28%, and the efficiency and cogenerative efficiency is 80%. As we see in the diagram, that first the waste is stored in the bunker, and then it will burn in the combustion chamber, through which the gases is used to produce steam, and through which we can generate electricity by running the turbine. Types of incineration process on the basis of their furnace: moving rate, fluidized bed, and rotary kiln. Moving rate is a process in which reciprocating rocking, traveling, or rolling movement to convey the waste through the combustion process. The efficiency of this process is 30%, and combined heat and power is more than 17%. Power efficiency of production capacity is 120 megawatt, and indicative cost is $450 to $700 per ton. The second process is fluidized bed. Fluidized is a technology of combustion of homogeneous fuels such as coal, raw lignite, sewage sludge, and biomass. It is combustion chamber in the form of vertical hot bed present in the lower section of the chamber. The power efficiency of this process is 25%. Now we are going to discuss a case study. Endeavour Dole plant produces electricity to house 107,000 household, and it supplied 30 TPH steam to the chemical producing company in OS. This Endeavour Dole plant produces energy with the help of moving rate technology and fluidized bed. Combination of moving rate technology and fluidized bed. So moving rate, it will use 4 lakh TP of waste, and it will also, and so fluidized bed, it will produce 6 lakh TP of energy. Rotary kiln is a process which is similar to the moving rate, but there is a main difference. Is it that here the waste is given to the secondary chamber by the rotating and rolling motion. The next process is pyrolysis. Pyrolysis is a process in which thermal decomposition of material at elevated temperature in inerted atmosphere. Material is exposed to high temperature and goes through chemical and physical separation into different molecules. It is mainly used for the treatment of the plastics, which is the main problem in our current world. The power efficiency of this process is 23%. There are three types of pyrolysis: slow pyrolysis, fast pyrolysis, and flash pyrolysis. Slow pyrolysis will produce charcoal in 60 to 70% ratio, and the fast pyrolysis, the main product of it is biogases, and in flash pyrolysis, the main product is oil. Gasification. Gasification is a process in which a reaction occurs between organic material at a high temperature, 500 degrees Celsius to 1800 degrees Celsius, without combustion within a controlled atmosphere. Through gasification, 80% of the chemical energy of waste is converted into syngas. The temperature range of this process is 500 to 800 degrees Celsius. Gasification can help to recover the energy present in the biomass and municipal solid waste by converting those material into valuable products and eliminating the need of incineration landfills. From December 2004, the Go Bios project in Gothenburg, Sweden, produced around 20 megawatt of natural gas from forest residue. The next process is plasma gasification. The technology reduces the content of 1,000 times less than the thermal gasification process. And the next process is anaerobic digestion. It is a biological treatment of process where microorganisms and used to convert the organic material into simpler forms. There are different types of process in anaerobic digestion, that is hydrolysis, acidogenesis, and methanogenesis. The power efficiency of this process is 40%. Tilburg plant produces 2.8 million meter cube of methane per year by using 52,000 tons of garbage and waste, vegetable waste. Because of the population boom, there is a rapid increase in the power consumption and thus increase in the production of waste. This situation favored use of waste as an alternative source of energy. If we are unable to manage our waste, the earth will look like this. As you see in the video that Earth becomes the dumping yard for waste, so to stop this, we should start planning energy from waste in large scale. Nowadays, Kanpur city is using this waste to energy conversion technology to produce 5% of their electricity, which is equivalent to 33 megawatt. At July 2017, thermal-based waste-to-energy plant in India have capacity to produce 53 tons of garbage and produce 63.5 megawatt per day. According to the new Ministry of New and Renewable Energy, the capacity can be enhanced by 1075 megawatt by 2031 and 2780 megawatt by 2050. At last, I want to say, the earth is loaded with the waste and slowly the earth is moving towards disaster. We, the youngsters, are the future of the nation and we have to take the steps to reduce the waste and produce energy from it before it's too late. Thank you.
Can I ask? Rupankar, what is a fluidized bed?
Sir,
What is a fluidized bed?
Sir, fluidized bed is a type of the incineration process in which the bed is constructed by the ash or sand, and in which the combustion takes place.
Why you call it fluidized? Why you call it fluidized?
So mainly fluid waste materials are used. That's why fluid materials are used.
No. Waste material, when you use, you will grade it, make it pieces, right?
Yeah.
So it doesn't become a fluid.
Yeah,
It is very much solid.
But in smaller particles,
But does it become a fluid if you?
no sir, the size will reduce. It will not become fluid.
Then why you call it fluidized bed?
No idea, sir.
How do you sample our waste? Methods of waste sampling.
Don't know, sir.
No idea.
No, sir.
Thank you.
Thank you, sir.
31. This one. I speak here. Both? Okay. Hello, everybody. First, I want to say that I am not author of this work. This work is a work of my colleague, who is Milka Uzunova. Milka Uzunova is from ECAM PME, and this work is between her and the team, a Bulgarian team, a team from Bulgaria. And the topic is about the possible use of hydrogen sulfide from the Black Sea. Okay. Okay, here you have the satellite picture of the Black Sea, and therefore Bulgaria is in this side, and therefore the coastline of Bulgaria on the Black Sea is very important. This is the reason why this university in Bulgaria is interested about this topic. The other countries, you have Romania, Russia, and Turkey. Yes, okay. Where is? Okay. Okay, very good. Thank you. Okay. The problem with here, the interest is hydrogen sulfide, and the problem that it is available, but in area which is very deep. The hydrogen sulfide is about here, near the bottom of the sea. Okay, and in order to get this chemistry, we need to use a boat. We need to use boat, and to go until some kilometers from the near shore, and to have adequate material, because and here we can see at which what is the variation of the concentration of hydrogen sulfide with the depth of water on the sea. And here you have until 2,000 meters, 2 kilometers. And you see that the concentration is important near the bottom. And therefore the study, this is preliminary study to know if this technique, or to go and to try to search hydrogen sulfide in the bottom of the sea, if it is interesting or not in economical aspect, okay? And what is the amount, what is the quantity which we can find? Okay, this is the apparatus. I will not speak much because I was not involved in this study, but the poster is somewhere outside. All the details are on a poster, okay? I give you the general informations, and if you want to know more, please go and read the poster outside. Okay, this is the apparatus, and the main thing with the apparatus is that at this depth, the pressure is important, and therefore they need to have a material apparatus which is adequate for high water pressure. Okay, and the aim is to use both hydrogen and sulfide from hydrogen sulfide, which is available in the bottom of the sea. And the main interest is that it is possible to use the hydrogen for the production of electricity, okay? And what is the technological scheme? Okay, I will present quickly the process, which is based on absorption, adsorption, and membrane separation. I will not go in details. And the first step of this study is mainly about the quantification and the first step of the economical interest. And therefore, the first study shows that 1 meter cube of water from the sea contains about 0.019 kilogram of sulfur, and other calculations allowed to find the hydrogen sulfide from the seawater, and at the end, for 1 meter cube from hydrosulfuric water, it is possible to get a concentration of hydrogen sulfide of about 12.5 milliliters by liter. And therefore, this is a good result, first preliminary good results, but they need to investigate more about the other condition, because in the sea there are conditions which are not taken here. The water in the sea is not quite. There are waves, there are currents, there are interaction between these, there are the sediments, there are morphological behavior of the bottom, of the sea bottom. And therefore the sea bottom is not regular, but especially near coastlines and near shore, the near shore and the sediments on the bottom moved due to hydrodynamic conditions. And therefore, this team, which is mainly involved in chemics, needs to work with the other teams in ocean engineering and coastal engineering. And therefore, this study is a multidisciplinary study which needs to involve persons from physics, from fluid mechanics, from civil engineering, and from chemistry and chemical engineering. Thank you very much for your...
Did you characterize the seawater?
Sorry?
Did you characterize the seawater?
Correct?
Seawater, ocean water.
Yes.
Did you characterize?
Ah, yes. Really, this question is more adequate for the authors. What do you mean by characterization?
What was the composition of seawater?
If you see the figure, the first figure, please. If you come back to the first figure, is it possible? We can see that the composition depends on the depth. And therefore, when you are near the free surface, you have oxygen, mainly oxygen. Mm-hmm. And when we go near the bottom, here, the first layer is oxygen.
No, not this.
Yes.
Like, did you take the seawater and analyze it for the contents?
As I said, I am not involved in this study. I am not the author of this paper. I am only presenting. And
okay. You have used particulate matter, right?
Sorry?
You mentioned particulate matter.
Yes.
What was size?
I mean sediments on the bottom.
No. Particulate matter you have used for the purpose.
About chemistry. You need
particulate matter.
Okay.
You mentioned in slide number 2 or 3.
Which one?
Next.
Okay.
What was size of the particulate matter?
Here.
Next.
Here?
No, but you mentioned it. You have not written it like this. All right, no problems.
Okay. The study is mainly in chemistry.
How did you use adsorption?
What?
How did you use adsorption for adsorption of H2S from seawater?
I don't understand what you mean.
You took out H2S from ocean water, right?
Yes.
How?
With this apparatus, but it is explained.
No. How can you take from this apparatus? You have to take ocean water and take out H2S using adsorption or absorption or some other processes which you mentioned.
But as I said, I am not involved in this study.
You're not involved. Okay.
I am only presenting.
Thank you very much.
Okay, I try to do the presentation for my colleague. But I am not I am not in chemistry. I am physics. In physics.
Thank you very much.
It's very difficult to speak about chemistry when we are in physics.
Thank you very much.
You are welcome.
47. paper ID 47.
Hello, good evening, gentlemen. My name is Akshay Suraj Jurandar, and I am from Srinagar College of Engineering, and I am going to present my research paper on the topic called Experimental Study on Effect of Water Spray Characteristics on the Performance of Cooling Tower. I have recently done my MTech. Completed. Yes. So these are the contents: introduction, literature review, experimental setup, spray characteristics, results, and conclusion. Introduction. Cooling tower is an indispensable part used as a direct contact type heat exchanger, and mainly for evaporative cooling. And it is used to remove heat from power plants. So in the present study, I have analyzed a counterflow induced draft cooling tower, and in the counterflow induced draft cooling tower, air is allowed to come from the top, and as it air come in contact with the falling water, the processed hot water from the power plant, the evaporative cooling happens. So in this study, I have checked a possibility of desired change with different spray angle, with different spray patterns, and I have tried it and analyzed. So these are the papers I have studied for. Okay. So this is the experimental setup. This is the cooling tower, and it is called as a package type cooling tower. It is induced draft cooling tower. It is called induced draft because at the top we have fitted an induced draft fan, which acquires air outside. So the first element is water distribution system. The spray nozzles I have fitted inside the cooling tower. The second element is induced draft fan itself. It is fitted at the top to extract the air from the atmosphere. And the third element is our fields and drift eliminator. The drift eliminator helps us to restrict the moisture going outside, so helps us to increase our efficiency. And there are fields on which the water spraying through the spray nozzles, which is splashed, and so that it increases the heat transfer area. And the fourth element is itself a body, a resin structured cooling tower body. It is called as packaged type cooling tower. And the fifth element is the water tank below it. So this is the experimental setup, and inside this we can see the spray nozzles are there. So they used these spray nozzles before, and they have a conical angle of 60 degree, and so certainly there were no so much efficiency as they desired, because they lack in working on the parameters like spray characteristics, and spray characteristics involved spray angle, spray coverage, and spray pattern. So I have checked a desired possibility, what may happen if we change the spray angle, and what may happen if we try taking experiment on different spray patterns. So a desired possibility is checked and analyzed. So at the top we can see the induced draft fan. In the middle we can see the spiral type nozzle and the full cone nozzle, full cone solid spray nozzle. The angle of this nozzle is 90 degree. And below we can see the fields and the drift eliminator above the spray nozzle. Now spray characteristics. So spray characteristics involve nozzle cone angle. Nozzle cone angle is basically the conical converse diverge angle outside, and it also involves coverage and spray pattern. Spray pattern is the pattern in which the sprays water. Sorry, the nozzle sprays water. The spray nozzle distributes the water into mini droplets so that enhancing the evaporative cooling as the air particle and the water particle come in contact with each other. So obviously it will affect the heat exchange so that the efficiency. Results. So all the performance parameters are recorded in quantitative form, and I have reached to the qualitative conclusions that I have acquired. So the basic parameter which give us an indication how well a cooling tower is performing are range, approach, effectiveness. Effectiveness is itself an efficiency about cooling tower, we can call it. So the observation tables are prepared and the trials are carried out, and as per the calculation, I have reached to the conclusions. We are going to see ahead. These are the considerations worth keep in mind. The inlet cooling tower temperature was initially nearly at the 50 degrees Celsius. Means the hot water temperature, means the hot water after getting processed from the power plant will be the inlet cold water to the cooling tower. So that temperature was nearly 50 degrees Celsius. And the initial load was 200 watt, and it was increased up to 300 watt. So it was remained at the load for 2 to 5 minutes in 200 watt of 2 to 5 minutes interval on 200 watt. So range and approach. Range is the difference between the cold water inlet temperature to the cooling water outlet temperature. So it is desirable to have lesser range. So the lesser is the range, the greater is the cooling tower is performing. So range is represented by the blue line. So for the hollow cone 60 degree, it starts at 9.5 degrees Celsius, and we need to reduce this range to possible minimum value. So as we go ahead, we found for spiral cone nozzle, we found 11.8 degrees Celsius of range, and for the full cone nozzle of 90 degree angle, we reached to 3.5 degrees Celsius of range. So this is the table in which I have included all the average results I have found. The first is for hollow cone 60 degree without prior induced draft fan, and the second is hollow cone 60 degree with prior induced draft fan. The third is hollow cone with 90 degree of spray angle, and the fourth is spiral type nozzle with 90 degree of angle, and the last is full cone with 90 degree angle. And as we can see, the range has been increased successively since hollow cone 60 degree. That was the previous case, existing case, and at last for the full cone pattern, solid spray pattern with a spray angle of 90 degree, we found, and we attained 15.5 degrees Celsius. The range is desirable to range is need to be increased. So we found that 9.8 to 15.5, and the approach is desirable to have less. So for the hollow cone it is 15, for hollow cone 60 it is 10.93, for hollow cone 90 it is 8.6. For spiral type, it is 9.1. And for the full cone, we have attained 3.56. And the effectiveness. Yes. Okay, sir. Okay, sir. So we found that the base suited spray angle, mean the conical diverge angle, is 90-degree base
It's
suited
okay.
angle.
You need not to read it. It's okay.
Okay, sir. Thank you, sir.
All right. What was temperature of water which comes out to your equipment?
It was 50 degrees Celsius.
No, 50 degree you display that is inlet temperature.
Yes, sir. Inlet means inlet temperature of cooling tower. The outlet temperature was 48, 49, 50.
Only. Only. वो तो अपने ही तरह ठंडा हो जाएगा. If you don't involve any equipment, automatically it will come down to 48 or maybe 45.
No, sir. If you run a plant, there is a mini steam power plant inside our college building. So we can't maintain. Means there is no chance that temperature will reduce by itself.
What about the experimental setup? This setup is like provided by somebody who designed this experimental setup for your experiment.
No, sir. It is the mini steam thermal power plant.
Oh,
Mini steam power plant.
okay, it's already existing there, right?
Yeah. So I have worked on the cooling tower and the nozzle of the cooling tower, means one of the accessory of cooling tower. And I have actually thermal performance. Actually, I have calculated all the thermal parameters and reached to the conclusion that than previous existing case, there are the new accessories and new spray angles, new spray patterns for which the efficiency can be increased.
But you have not displayed it there.
Yes, sir. I have displayed.
Well, did you compare it with the existing results?
Yes, yes, yes.
Last slide. Okay, you can continue.
Okay, sir.
What is the water flow?
Sorry.
Value of water flow?
Water flow.
Because you are saying inlet temperature is 50, outlet temperature is 48, 49. So what is the water flow? Okay, you can
So
tell later.
okay, sir.
Yes, we'll discuss later.
Thank you, sir.
Paper ID 39.
Hello, everybody. My name is Marwa Yassi. I'm PhD student at ECAM PMI and at the University of Cergy in France. Today, I will present my study concerns effects of PCM using in building thermal comfort application through several climate conditions. So today, the energy transition is above all an ecological objective. So the main change today is to reduce consumption, energy consumption. So we therefore want to improve this sector. See, it's a building sector, is largely responsible for CO2 emissions by avoiding thermal comfort. By improving thermal comfort, avoiding cooling and heating systems, and increasing energy savings and reducing energy consumptions, and therefore improve thermal inertia in the building. So to solve this problem, the integration of PCM phase change materials in building is a solution, an interesting solution. So PCM phase change materials have the ability to store thermal energy and reuse it in order to control control the temperature with specific range, and then to improve thermal comfort to the inhabitant in building. So we can see a graph with which can illustrate an overview of research on the use the PCM into the building wall. So we can see that has been real progress in recent years. So PCM today, they are integrated in different forms. They are often integrated in as lightweight panels, lightweight board, or encapsulated into the building materials such as plaster, concrete, or bricks. So here we have an example of concrete that has been studied in Portugal. This concrete encapsulates a PCM manufactured by the company BASF. And the study showed a reduction of 2 degrees on the indoor temperature by comparing it to an ordinary concrete, so concrete without PCM. We have another example from the same company, BASF. It's a smart board with 1.5 centimeter of thickness, and that has the same storage capacity as 9 centimeter of concrete or 12 centimeter of bricks. Another example of PCM as lightweight panel, it's BioPCM manufactured by the company Phase Change Energy Solutions that had been studied in Oslo in Norway, that has been studied, and the results showed that we can decrease the ambient temperature of 3.3 degrees by comparing it in an ordinary wall without PCM. So this study is a comparison of 3 experimental studies with the same PCM on a typical summer day and in different climates. So the main objective is to evaluate the impact of PCM into the building thermal comfort applications, and raise awareness and encourage all builders to use this material. So the PCM used is about 16% microcapsulated paraffin, and this PCM was manufactured by the company Dupont de Nemours, and we can see some of thermal physical properties like thickness and phase change temperature, which is melting temperature and solidification temperature, and latent heat. So for the first experimental study, it was carried out in Lyon, which with the oceanic climate, which is characterized by humid winters and cooler summers. So the PCM was integrated on all 3 walls, west, east, and north wall, and the graph showed, the results displayed showed that the integration of this PCM allowed the east, the north, and the 3 walls to reduce the temperature with a maximum of 3.5 degrees. The second experimental study was carried out in Reading, in England, with the same climates, oceanic climates, and we can see that the results showed that the application of this PCM can reduce the interior wall temperature of 1.3 degrees. And for the third experimental study was carried out for 2 cubicles at Faculty of Science in Casablanca with a Mediterranean climate, which is characterized by mild and humid winters and hot and dry summers. And but the results showed that the PCM can completely destroy the thermal certification, but decrease ambient temperature in the cavity with PCM. Sorry. So by comparing the three studies, we can obtain with the oceanic climates a decrease of temperature, of ambient temperature in the cavity with PCM. And for the case, in the case of Casablanca, the temperature was higher than cavity without PCM. So in conclusion, the use of PCM in building have the ability to reduce the ambient temperature, to improve thermal comfort, to also minimize the thermal stratification and to reduce energy consumption, because we tend to minimize the utilization of cooling system in our case, and the results depends on, of course, the climates of the place where it will be integrated. So in the future, we would like to evaluate the PCM under other climates, like Parisian climates, or evaluate several layers of this PCM. Thank you for your attention.
PCM is supplied by some company outside.
Sorry, PCM? Ken?
Is supplied by some other company.
This one?
Yeah.
Dupont de Nemours. The company is Dupont de Nemours.
And you procured PCM from that company?
If I worked with this PCM?
Yeah.
Is the question?
Yeah.
No, because they don't work. They stop the marketing of this PCM.
And why you carried out a study at 3 different places?
Because for thermal comfort, we have to evaluate this aspect to vary the variation of climates, because we cannot integrate a PCM in several climates and have the same results. So it's the aim of this subject is to highlight the impact of the climates on the integration of PCM and its passiveness, its effective passive effectiveness.
So you carried out these studies at the 3 places?
Sorry?
You carried out the studies?
No. It's studies carried out by other authors, because they.
Who are there in the paper? All other authors are there?
Yes. The results, it's experimental studies. Okay. Was carried out in Casablanca and Lyon and Reading.
Okay, what are you doing? You are a PhD student?
Sorry?
PhD student?
Yes.
Oh.
I just compare, because I cannot do an experimental study because it's too long to have a PCM, and for the future we would carry out a numerical study. We are working to do this.
Thank you.
Thank you.
Okay. Yes.
1 minute.
Because it's a conference. Everybody is not a jury of.
Yes,
papers.
of course.
Okay. Yes, thank you for this presentation. My question is about what do you think about the practical use of actually the PCM?
Practical use?
Practical use. Now, what is about PCM in practical construction in buildings? It is used now?
Yes, it is used, by, for example, in Palais of Tokyo, in Paris. It was used for a renovation of this PCM, the Dupont de Nemours. Because for the renovation, it's easily to use, because we have just to superimpose this PCM to the ordinary, the existing wall.
Okay, and why they stop it to the commercialization of this?
Because it's so expensive for builders. It's cost too much expensive than other building materials.
Okay, thank you very much.
Okay.
Thank you.
Okay.
Next, paper ID 64.
Good afternoon, everyone. I am Nikhil Shivadaka, MTech second year student from Construction Technology and Management from NIT Warangal. So the topic of my presentation is adaptive lighting comfort in the classrooms of educational building and student hostel rooms. It's a case study done in my college only. So this presentation contains the introduction part, the literature review I have done, the objective of the study, methodology adopted, data collections, then the analysis of the questionnaire survey I have done with the studies, resultant discussion, and the conclusion part. So coming to the introduction, lighting comfort can be described as a satisfaction of the residents in an indoor environment. So it is a perspective view. The lighting comfort in the same environment cannot be same for two persons. One person having a lighting comfort can be different from the other person only. So it is depend on the quantity and quality of the light within any given space at a time. So there are various factors we can in general contribute to the lighting comfort. These are the intensity of the lighting, the quality of the lighting, it is the illuminance uniformity within the room, the distribution of the indoor light, color characteristic of the light, and flicker rate and glare. So mainly two code books are adopted for the study. It is the Chartered Institution of Building Service Engineers and Interior Lighting Illumination Engineering Society. These both are American code books. The same for the Indian scenery is National Building Code that we have for the Indian studies. And it is that I have done for the classroom conditions because it is said that indoor environment condition is very important for the teaching learning process. And it is said that the stress hormone known as cortisol, it is more regulated by daylighting other than the artificial lighting. So daylighting is more important for students other than artificial lighting. So these are the literature reviews. For time and space constraint, I only put a few of the literature reviews here only. Now coming to the objective, the preliminary objective is the study of the indoor daylight comfort in the classrooms and the hostel rooms. Then the collection of the intensity of the lighting using a suitable instrument at a particular space and a particular time. And then the analysis of the recorded data correlating with the questionnaire surveys I have done with at the same time I have taken the readings. So the methodology adopted is, I have taken the MTech classrooms of Civil Engineering Department of NIT Warangal and a hostel, it is G+9 hostel, 1.8K ultra mega hostel. So the size of the studied classroom are same, but the external environment condition is different, making the different indoor lighting environment within the classrooms. And same in case of the hostel rooms, the size of the hostel rooms are same, but the orientation of the hostel rooms are different, making it different indoor lighting environment. So this is a 3D model of the hostel I have studied, 1.8K hostel. So the red dots are the different position of the hostel rooms I have adopted to study at the different floors. So this is the instrument, it is HTC LX103 digital lux meter. By using this instrument, I can measure the intensity of the lighting at a particular position. So I have collected data from the classroom hours only, from morning 8 a.m. to evening 5 p.m. on the hourly basis. And data was taken at different positions within the room. So I can define what is the difference in the distribution within the room. And in a questionnaire survey using Google Form was done at the same time. The time I have taken the data, I have distributed the Google Form within the students so that I can see the perception of the students. So these are the data collection analysis. I have shown only a few tables here. So this type of data I have collected from morning 8 a.m. to 5 p.m. at different position of the rooms. If I have done the graphical representation of the same, that how it is varying within the hourly basis at the daytime. And I have taken the average of the data and see how it is changing within the day of a particular week. So when I come to the analysis, graphic analysis in the hostel rooms, I have seen that this is quite different within the same hostel. The hostel is quite large. It is the east-facing room have quite bright morning lights, so they don't use artificial lighting at that time. But the problem with the west-facing viewing is that they don't have any particular daylight at that time, so they have to use the artificial lighting. And this is the change in data from one position of the room to other position of the room. We can see that near the window, the intensity is quite high, but towards the farthest side of the window, the intensity is quite low. So distribution of the room inside the building was not very good. So the analysis of the questionnaire survey, I have done the p-value test by using the IBM SPSS software to check whether the collected questionnaire survey can be used or not. So we have found that the significant level was 0.01 for a given variation, and for two variants, it is 0.05 level. So I have done the questionnaire survey on a 9-point scale to find out what is the perception of the students. So it is shown, it is for 9-point scale, the 1 referring to extremely unfavorable condition, and 9 being the extremely favorable. So most of the students there shows the indoor lighting conditions that they are favorable, and daylight distributions only. And problems due to lighting. For higher intensity of lighting, various students face different types of problems like glaring, thermal irritation, flaking, etc. And it is the effect of lighting on the mood of the students, and how they are feeling when the intensity of the lighting changes throughout the day. So this is the result I have got. I have said that in the building codes mainly said that for classroom conditions, the minimum intensity of lighting should be 500 lux. But I have got that even below that lighting intensity, the students feel quite pleasurable, and the artificial lighting was needed by the students for lighting intensity of 200 to 250 lux. And for that particular scenario I have studied, 250 to 400 lux was the most comfortable range of daylight lighting students preferred. And most of the students said that they prefer daylight over artificial lighting, which was again I got from some literature reviews again. And they said that when the lighting, indoor lighting was very dim, they feel sleepiness and cannot concentrate on the studies, and due to sudden change in the glaring of light or flickering conditions, they have the lapse in concentration while studying. So these indoor conditions should be avoided in the classrooms. So in the conclusion, I have got that the indoor lighting is a very important factor for comfort condition inside the room, especially for the students. And we should have more efficient window design while constructing a building, so that the indoor lighting condition can be controlled properly. And now with the use of building information modeling and automation softwares like Navisworks and all, we can easily design comfortable conditions for classrooms. And the scope for future research is very high in this field, and more people are given emphasis on the comforting condition of the classrooms. These are the references. Thank you.
What is, in your opinion, what is application of this study?
Sir, by using this study, we can see that more of the students can prefer daylighting over artificial lighting. So many of our classroom now, you can see that in this is not a classroom, it is a seminar hall, but we are using more of the artificial lighting here only. But we should emphasize mainly giving the daylighting conditions to the student rather than artificial lighting.
How can you do that? Like classroom is
Sir,
enclosed from the walls, and like if I take class in my institution, we have to use enough light, no? If
Yes,
you
sir.
don't use enough light, it is always a problem of sightiness. You cannot look at the things sharply.
Yes, sir. Sir,
More so, do you like, I have never bothered that what is intensity of the light. We take some bulbs or LED lamps or something and then use it. So that study becomes a bit different, no?
Yes, sir. Sir, I have not actually studied for the implementation part yet now, because I have my second semester of the second year in the MTech. I am planning to do the implementation part in that part only, but sir, I have studied a factor called window to wall ratio. It is the what should be the proportion of the window in that wall for a particular, you may be bedroom or classroom or seminar hall or office building, like that only. So different use of the building, the window to wall ratio is different, according to which the amount of lighting intensity coming inside the room is also different.
See, that can happen only if you have enough land around you. In cities like NIT, what you are saying, Warangal,
Yes, sir.
or any other NIT, old NIT is okay. But then if you construct a new building, you don't have that much of space anywhere. So this is my concern. We can propose anything, but then it probably loses practical aspect.
Yes, so in practical aspects, some special paints are there. If we can use this type of paints inside the building, it reflects maximum amount of light. So then the small amount of daylight coming inside the room can be reflected to make the whole building more luminous. Like that only. But sorry, sir, I have not studied properly about the implementation yet. No.
No problem. Thank you.
Yes.
Anyone else? Any question? Okay. Thank you. Next paper ID 112.
Good evening, one and all. Myself, Dr. Nishigant Pandey. Today I'm going to present a topic that is poly and methyl aniline lithium nanocomposite as an electrolyte for rechargeable battery in situ recip. Content, objective and scope of study, introduction, literature survey, synthesis of an electrolyte material, characterization of material, application as battery, and last is conclusion and future scope. Objectives and scope of study. So I have synthesized lithium nanoparticles with the help of Plumeria rubra flower extract. And in continuation, I have prepared the composite, that is a poly and methyl aniline lithium nanocomposite. And that material I have used as an electrolyte material for battery. Introduction, what is nanoscience, nanostructure, nanotechnology? Nanoscience is the study of the fundamental principles of molecules and structures with at least one dimension is in the size range of 1 to 100 nanometer. These structures are known as nanostructures. Thus, research and applications of nanostructure into nanoscale devices is called nanotechnology. And I have shown one graph. If the particle size reduces, the nanoparticles are formed and the band gap is more, particle size reduces. After the literature survey, what are the conventional techniques for synthesis of nanoparticles? That are Sol-Gel method, then colloidal method, solvothermal method, electric arc deposition method, laser pyrolysis, solvochemical analysis, then vapor phase method. And I have chosen here the conducting polymer material, that is a poly and methyl aniline. Why I have chosen this? Because it's a good electrical conducting material, it's lightweight, anti-corrosive material, it's inexpensive, and also it is a good for chemical vapor sensing purpose. So synthesis of lithium nanoparticles, I have told, so I have taken a Plumeria rubra, then I have taken extract of it with the help of Soxhlet apparatus, and then from that Plumeria rubra I have extracted the quercetin, and then I added the lithium nitrate in it, and the nanoparticles are developed in presence of ultrasonocator. So this is a reaction how I have developed this lithium nanoparticles. From the Plumeria rubra, I have extracted the quercetin, and the right hand side there are two OH groups it's converted into the dihydroquercetin and lithium nano developed, and byproduct is a nitric acid. So in continuation, synthesis of poly and methyl aniline lithium nanocomposite. So lithium nanoparticles are there in the beaker, then add the monomer, that is a N-methyl aniline in it. Then add acid, that is a tartaric acid in it as a doping for doping purpose. Then add oxidizing agent, that is ammonium persulfate in it. Stir the reaction mixture for 20 minutes at temperature 0 to 5 degrees centigrade, and the poly N methyl aniline lithium nanocomposite it's developed. So I have shown here the tentative reaction mechanism of it. Yes, sir. Ammonium persulfate. Yes. Shall I go, sir? Yeah. So this is a tentative reaction mechanism of developed material. So this is a three-dimensional structure of developed material. So after that, characterization of synthesized material for UV visible spectroscopy, FTIR, X-ray diffraction technique, and FESCM. So in the UV visual spectra, the absorption band of acidic range was observed at 265 nanometer. Then the absorption band at 370 pi to pi star transition for a benzenoid ring. Then at 450 we observed the N cunoid ring, and at last there is a increasing towards the 800 nanometer. Means what? It's a ambivalent state. It's a conducting material of the poly and methyl aniline. In FTIR, the stretching frequency we observed for NH in the range of 300 to 3000 to 3600 per centimeter. Then for CH stretching, it's in the range of 3000 to 2800. Okay, fine, yeah. So these are the, after that after that X-ray diffraction studies for semi-crystalline polymer material, we observed the peak at 22.30 for 2 theta, and the remaining peaks are observed for the lithium nanomaterial. So I have calculated the particle size of lithium nanoparticles by using a Debye-Scherer's formula, that is diameter of particle is equal to the 0.9 into lambda upon beta into cos theta. Beta is a full width, half maxima, and lambda value is 1.54 angstrom for the X-ray. So this is a first emission scanning electron microscopy. If you'll see there, the very small, the spherical shaped lithium nanoparticles are present in material. Field emission scanning electron microscopy means on the material, if it will pass the radiation, you can observe the surface structure of the material. After that, the poly and methyl aniline, there is a nanofiber kind of structure we observed. The range of nanofiber structure is in the range of 300 to plus or minus 50 nanometer. Then application as a battery, in short, I'll tell you, I have taken one hollow aluminium pipe. The size of the hollow aluminium pipe is 5 centimeter. And I have sealed one side of the that battery, that pipe. Then inside there is a copper coil I have taken as a cathode, and electrolyte material, synthesized electrolyte material I have taken 2.5 ml. So after completion of that, the potential developed is 7.08 volt, the current developed 4 milliampere, and after 100 cycles of charging discharging, it shows the same temperature. I'm sorry, the temperature is increasing little bit. After that, the battery is showing the increasing temperature, but the voltage remains same. This is a possible reaction mechanism of electrolyte for charging and discharging. I have checked for different resistance, and I have found out the power density of battery, that is with the help of these two equations. So the power density of my battery is 119.233 watt per meter cube. Conclusion, developed material shows outstanding result as an electrolyte FESM network between nanofiber and spherical shaped lithium nano. After 100 cycles shows good storage capacity and future material for the e-vehicles. This is a future scope of it. Yeah, yes, sir. Is that reference? Thank you, sir.
Who got Nobel Prize in chemistry in 2019?
Sorry, sir, pardon, please.
Who got Nobel Prize in chemistry in 2019?
Okay, 2019. That is for the lithium-ion battery.
Who got it?
I'm sorry, sir, I can't recollect right now.
Which country produces, rather, which are the countries which have largest reserves of lithium?
I think Germany.
No.
Okay. Sorry, sir.
Congo and Argentina. Congo and Argentina.
Okay, Congo and Argentina.
Congo and Argentina.
Okay.
Okay. You displayed that 1 to 100 nanometer is not a nanomaterial. If it is 100 nanometer, it is not a nanomaterial. You should be clear about it. Number 2, how did you determine size of the materials you produced? You say it is a nanomaterial.
Yes, sir.
How did you measure the size?
So with the help of scanning electron microscopy.
You cannot determine size with scanning electron microscope or even XRD. You can calculate with the help of XRD.
Yes, sir, I can calculate with the help of XRD.
But you cannot determine. You can determine size of nanomaterial. You should use TEM.
Yes, yes, sir. Transmission electron microscopy.
You have
yes,
to
sir.
use TEM for size determination.
Okay.
Right?
Because it's gone inside the material.
Whatever that you
fine.
study, and then that is what
Okay,
your
okay.
own classification.
Yes, sir. Yes, sir.
And then semicrystalline. What is semicrystalline material?
It's a polymeric amorphous kind of material.
Amorphous is different and crystalline is different.
Different. Yeah, semicrystalline, generally the polymer materials are semicrystalline material.
What is semicrystalline?
So partially crystalline, partially amorphous.
वो कैसे होगा? No.
Okay, no, sir.
And then you say nano composite, but you have not confirmed this is a nano composite which has been formed, or even composite. What is a composite material?
Means you mean to say the ERAX method? You want the percentage of elements?
I do not say anything. I am asking you.
Yes, sir.
When you have synthesized the material, it's basically your research work, no?
Yeah, yes, sir. It's just a nano composite means
No.
in the actually.
If a material is formed, and if you claim that it is a composite, you have to ensure it is a composite. If you claim it is a nanomaterial, you have to assure that it is a nanomaterial.
Okay.
So this is my comment.
Okay. Yes, sir.
Anyone else? Thank you, sir.
Okay, yeah. Thank you, sir.
Next paper ID 120.
Good evening, everyone. Myself Anju Vanti from PTA College of Engineering, Gulbarga, working as an associate professor over there and pursuing my PhD. So today I'm just presenting a paper on vernacular passive cooling systems. Like nowadays, what is happening is about the energy consumption. It's a big issue about the global warming and all such sort of things. And maintaining the sustainable environment, we speak so many things about sustainability, about the environment and everything. Here I would like to focus upon the buildings, how we can create a climate responsive building wherein less use of mechanical devices can create a thermal comfort for the inhabitants of the building. Here, like nowadays, it's a burning issue of the global warming and all, wherein all the natural resources have been used rigorously. And so for this purpose, actually, we need to go into the history of the residences, that is about the vernacular architecture. So in the vernacular architecture, the residences which our ancestors built were generally consisting of the local materials available in their area, and that construction techniques also which they used were very simple. Here, generally going deep into the vernacular features of our own India, like even in Rajasthan, mainly I'm dealing with the hot dry region, wherein the temperature goes up to 25 to 42 degrees, and generally I'm taking my own region, that is Gulbarga, which is a hot dry. It's a case study done by me. It's of Gulbarga district only. Generally, when we speak about the vernacular architecture of India, in Rajasthan, even Rajasthan is a hot dry region, there in Havelis and all we see the water bodies and the open courtyard available, so that the environment and the surrounding over there is cool with the water evaporation. And the main design process, the things which we look into the design process are the main aspects like the planning decisions, the functional decisions, and the material decisions. Generally, in the planning decisions, what happens is when there is a group of housing in the hot dry region, we go for a compact planning so that there is a mutual shading created between the buildings so that we get the shaded narrow pathways or the narrow lanes. Whenever we go to the older regions, particularly in Gulbarga and all, we find very narrow lanes. There were no roads, no roads with a wider, width and all. So we found very narrow lanes which were the access to the residences. So these lanes were mutually shaded by the shade created by the building. So in this way, when they were compactly arranged, the area would be cool, it wouldn't be very hot. Then apart from that, when we go to the individual housing plans, the rooms which are the rooms wherein the activities takes place more, those has to be placed deeper inside from the main sun radiation area. As we can see, the sun rays will be very less as we go into the depth. And one more, the planning concept is providing a courtyard in between the residents. Courtyard with the plantation as well as a water body will create a cool environment here. And this type of planning is generally adopted in the hot dry region because here we find cold environment during the daytime when all the activities, household activities are being carried out in the courtyard which is provided. On the aspect of the functional decisions, the openings were provided, very smaller openings were provided in the buildings as we see there on the right side, and these openings were used for various purposes like the physical access. Physical access is access to the residence, and it would act as a fresh air inlet as well as the ventilators which were provided at the top of the building, which were closer to the roofs were used for the hot air to get outside. Generally what happens is when the fresh air is entering inside the rooms, the air is heavy when it is cold. So it is at the bottom of the room. And when the air is hot, it gets lighter in weight and it goes to the top surface of the roof where the ventilators are provided near to the roof. So through these ventilators, the hot air is getting outside and creating a comfortable indoor environment. Apart from that, these openings are used for the lighting purpose and for the visual access as well as for the audial access. Next point which we need to consider for the vernacular aspects are the materials related to the construction. Generally what the materials they used were found in the local region, like what all the materials were available, those materials were used for the construction purpose. Generally in our area, like nearby Gulbarga, we would, it's very famous for the Shabat stones which are available, and the older buildings or the vernacular residences which we see in the villages and all, those residences were totally constructed with the help of Shabat stones. They were up to G+2 also. And here they were not using any mortar for the construction. Only the placement of the stone was done in such a way, the building, the houses are still 150 to 200 years old building we can see in our region. And the other important aspect which we need to consider is the thickness of the wall. The very massive walls we would find, we can find out in the older houses in the hot dry region of Gulbarga. The thickness of the wall varied from 45 centimeter to 60 centimeters. Here what happens is when the heat penetrates inside the residence, it takes time to enter inside. So the time lag which is there, by the time it enters inside the room, it is around 10 to 12 hours. So during evening hours, the room inside will get hotter. So in summer, generally, people prefer to go to the terrace for sleeping. And in case of roof construction also, the thickness of the roof was from 15 to 30 centimeters. And generally the beams were made up of timber. Later on, the timber was replaced with the steel I-joist beams also. And even on that, mortar was placed and Shabat stones were laid for the roofing purpose. This is about my case study. This area, climate of this particular area is hot dry. It's a residence, 150-year-old residence belonging to the village head, and it is located in a village called Alur, which comes under Chittapur Taluka. Again, Chittapur Taluka comes under Gulbarga district, which is in Karnataka. About the house, you can see the main facade of the house here. Okay, I'll just quickly explain in the plan itself. So this is the plan of the house. Here, starting, we have the entrance towards the northern side. The main entrance door is there. As soon as we enter the main door, we find a Jalja kind of platform on both the sides. And after Jalja, we find the courtyard in between. And all the rooms are surrounded around the courtyard. Here we can see on the left and right side of the house, we would find the mezzanine floors also, and there were two entries for the residents. One was the main entrance for the people, and the other entrance was very small. That was a cow shed. Cow shed also was provided at the main facade of the building. Then all the rooms, the kitchen was at the interior part of the house, wherein all the ladies used to be busy in working, all the private works used to be carried out inside, and even the courtyard also was used for the activities. This particular house consisted of 2 floors. Okay, I'll go for the concluding remarks. The energy consumed in the residences for the thermal comfort can be reduced by the climatic consideration of that region by using a better degree of natural conditions. The most important factor is the relation between the interior and the exterior environment, building form, orientation, and the material use. Considering the sun path and the wind direction create the natural comfort in the building. In hot dry climate, the building orientation should always be north-south, that is the longer side of the rectangle should be facing along the north and south. Landscape can also be passive cooling techniques, which controls wind, solar radiations, and the extreme temperatures. Along with the wind directions, if a buffer space such as a water body is provided, then the intensity of the heat is reduced due to the evaporation of water, and it reaches inside. All the service areas like the toilet, stairs, stores can be provided on the western side so that the other habitable rooms are cool. And the courtyard is an important feature of the vernacular architecture. All the rooms of the house will be surrounded all around this rectangular opening, which act as a source for the natural light and ventilation and provide the shaded spaces. Thicker walls act as a cooling technique as the intensity of the heat reduced by the time it enters inside, thus providing a comfortable indoors. The window sizes are small and the window sill is also high, thus reducing the heat gain and increase the light penetration. Ventilators are also provided very high and thus it helps in removing the hot air from inside. Thank you so much.
Speaking regarding temperature or energy, I understand that for a technical paper,
yes, sir.
You should have done some measurements of.
Yes, sir. Simulation of the building is yet to be done, sir. These are the basic things which are needed and the vernacular features which were adopted in the olden days. So that I'm just finding out those techniques now. So the main aim of my research is integrating these vernacular passive cooling systems into the modern buildings. And for this objective is finding out those techniques first. So this is the basic paper.
Okay.
In further, I will be doing the simulation
Absolutely.
of the buildings,
Absolutely.
in which each and every material simulation will be done. Sir.
Thank you.
Yes, sir. Thank you, sir.
Okay. Anyone else? Any question? Okay. Next paper ID 156.
So, good evening one and all. I am Tushar Raktate and currently pursuing MTech structure from Sandeep University. So today I am here to deliver a second year. So today I am here to deliver the presentation on design of monopile foundation for offshore wind turbine under the guidance of Professor Ron Chaudhary sir. So we will start with the presentation. We will start with the introduction. Then in that we will see what is actually the monopile. Okay, so we will start with introduction. So as we know that India is having the highest population followed by the China, and there is huge requirement of electricity. So to generate the electricity, there are different ways. So wind turbine is one of that. So basically there are two types. One is onshore wind turbine and another one is offshore wind turbine. Onshore wind turbine means, onshore structure means basically onshore structure are those structures which are constructed on the ground, and offshores are those are constructed on the water surface. So offshore wind turbines are the reliable source of renewable energy. So now India is moving towards the offshore instead of onshore, because there are some favorable factors like higher wind speed, lower visual intrusion and noise, easy transportation, and the lesser transmission cost. So, and India is currently ranked as a 5th onshore wind market in the world, as there are some countries like Denmark, UK, Germany, they are having a 40% contribution of wind turbine, and that is 1/4 contribution from the offshore wind turbine only. So, there is a integrated perspective of energy use and reliable resources are accounted for the 12.2% of India's installed capacity, with 70% contribution from the wind sector only. So these are the two figures which shows the monopile and transition piece. So first figure shows the monopile diagram. What is monopile? Monopile is actually a steel hollow pile which is having a 5 to 8 meter diameter, and generally it is used generally up to the 40 meters into the seabed. And another figure is a transition piece which is mounted over the monopile. These are some literatures which I have followed. So actually there is, I have followed one 2017 and 14, and this 2009, these are the two literatures which gives me the statistical analysis, multivariable linear regression analysis. For that, I have selected these two, and I have followed 20 to 24 literatures, but for the slide constraint, that's why I have only mentioned over 4 years. So objectives and scope. So to obtain the preliminary configuration, that is pile length, pile diameter, and the thickness of pile, this preliminary configuration or pre-feasibility study has to be done. So pre-feasibility studies involving estimation of preliminary dimensions of the offshore wind turbine. As there is a 20 to 25% of 20 to 25% of cost is carried by the foundation itself. That's why the pre-feasibility study is the most important. So parametric studies are carried out on the various configurations such as different water depth, different current speed, different soil angle friction, and a nonlinear static analysis of substructures by using the aerodynamic, hydrodynamic, and soil interaction ratio. Now we will start with the methodology. So this is the location of site. This is 23 to 40 kilometer away seaward side from the Gulf of Khambat of Gujarat, and the proposed location is Zone B. So I have taken this site for the calculation, and this is the methodology. By modeling the offshore wind turbine in the SACS software and doing the static analysis. After doing that, I have checked for the rotation 0.22 for the static analysis, and unity check is 0.8. After obtaining the outer diameter and pile length, that stored data is being tabulated, and after doing the multivariable linear regression analysis, I have got the preliminary design results. So this is the figure of SACS modeling. This is the actually monopile design, and after applying the load, I have get some results, and I have tabulate that results, and after that I have do the statistical analysis. So results, as I have already said that after doing the modeling and doing the analysis by using SACS software, I have come up with some results. And for the validation purpose, I have done the multivariable linear regression analysis, and after that I got the two equations, first for the diameter and second for the length of monopile, and where for the diameter 4.25 plus 0.072 into WD, where WD is the water depth, and 0.11 into C, where C is the current speed of water. Then L is the length of monopile, where 56.52 minus 1.397 into SA is the angle of friction of soil, and 1.138 into Mi, where Mi is the moment of inertia of that monopile. So the predicted model is validated using the 8 different cases and corresponding results from SACS and predicted design equations for the pile length and pile diameter. So these are the some graphs. This graph is for the comparison of actual value with predicted model for pile diameter, where first PD1 is the pile diameter by using the SACS model, and PD2 is the pile diameter by using the nomograms or equations which I had carried by the statistical analysis, that is regression analysis. And this second figure is for the pile length, and the same, that is PL1 is by using the SACS software, that is pile length, and PL2 is from the nomograms. And for the thickness there is one formula in API code, that is 6.25 plus D by 100. By using that formula we can easily calculate the pile thickness. So these are the three basic dimensions. Dimensions we can calculate by using the study. So conclusion. So to study the proposed equation and nomogram, the basic by using this study we can easily calculate some equations by using that analysis. Then equations, these are equations are applicable for the any locations which are having other locations which are having the same geotechnical or meta-ocean data. Then time and efforts required for the pre-feasibility studies are the minimized. So as we know that there is so many analysis and design time is required. So by using this equation we can easily minimize the time. And for the future study we can predicted model by considering multi-layers of soil. As I have selected a single type of soil and different angle of internal friction. But for the future study we can do the calculations for different multi-layers, and we can also do the finite element modeling, as now FEM analysis is most important. So finite element modeling to generate P-by curves. So these are some references, and for the design purpose I have followed the code API, that is American Petroleum Institute twice A, and DN Visual, which is a Norwegian code basically. And for the wind calculations I have followed the IS 875 part 3 Indian code. And these are some websites and books which I have followed for the calculations. So thank you.
Why have you chosen older literature?
So actually I have selected so many literatures, but first two literatures are for the design of monopile and second two literatures are for the statistical analysis. That's why I have mentioned two literatures over there, that old literatures. Sir, actually now we are moving towards, instead of onshore wind turbine, we are moving toward offshore, as our Honorable Prime Minister Narendra Modi has announced that. No, sir. Sir, these nomograms, I have concluded that nomograms, that two equations, after doing the analysis, regression analysis, I have concluded that two equations, and by using that two equations, we can easily calculate we can easily do the pre-feasibility study. So it is a kind of analysis which we can do in the Excel. It is a kind of analysis which we can do in the Excel.
For this particular analysis, where from did you get the data?
Sir, that software we use, SACS software, and from that data we have modeled 80 models by different parameters, by different design parameters. We take 80 models, and after that getting the.
You are simply displaying two equations. Two equations are two models.
Two equations are.
These are algorithms, no? These
Yes.
equations are algorithms.
Yes.
No, generic algorithms, no, nothing more. So for this you need to have a lot of data.
Sir, for this I have taken design parameters and I have done the 80 models on that software, and after getting the results of that 80 parameters and that model, after by taking that data, I have put into the regression analysis and I have generated that two equations. And for the multivariable linear regression, for that I have to also do the ANOVA analysis, and after that
that is okay. If you got any data, you can carry out ANOVA. For how much of the size of data did you do this ANOVA?
So actually
you have not displayed the ANOVA results here.
So I have mentioned in my paper 5 internal friction, 5
No, it is not. I am talking of the work which you are presenting here.
multivariable linear regression. There are different processes. There is algorithm to analyze that regression analysis. For this, ANOVA analysis is required. First, we have to do the ANOVA analysis, and after that, we have to do the regression.
ANOVA, gentlemen, ANOVA you apply when you have enough data. If data set is very small, ANOVA has no meaning.
Sir, yes, that's why I have taken 80 models.
Tushar, only one question. Design of monopile foundation. Sure.
Yes.
In that, in both of the equation, density of air, density of water, chemistry of water doesn't play the role.
Sir, it is a pre-feasibility study. Means if by doing the pre-feasibility, we just come to know that what are the different dimensions, and after that we have to do the lot of analysis. There are fatigue analysis, transportation analysis, in-place analysis in offshore industry. So if we do the pre-feasibility, it will easy to do the further analysis. So that's why I have done the only pre-feasibility study.
Okay.
Thank you.
Thank you. Next paper ID 170.
Good evening, sir. Myself Mayur Jadhav. I am a MTech second year student from Government College of Engineering, Karad, and my topic is application of additives with gasoline fuel, a review. It is a review paper. I will be presenting a review paper here. My guide name is Swati Jadhav, Professor Swati Jadhav, and Dr. Supriya Chauhan. These are the contents. Introduction. So world energy demand is increasing day by day due to exponentially increasing population. Also the prices of fossil fuels are rising due to increasing demand. The fossil fuels are having environmental impacts such as acid rain, ozone depletion, greenhouse effect, and are causing the environmental deterioration. Worldwide research in the field of alternative fuel sources for engine is hence going on. So coming to the chemical structure of gasoline, gasoline consists of C4 to C12 hydrocarbons, and gasoline is a mixture of alkanes, alkenes, and cycloalkanes. The chemical formula for the gasoline is C6.97H14. So now coming to the BS6 standards. BS6 standards will be implemented from April 2020. And that's why we need to scale down our emissions from the vehicles. This is the graph of BS6 standards for SI engines. As we can see, for hydrocarbon emissions, for all types of vehicles, there is no change in the HC emissions from BS4 limit, whereas for NOx emission and CO emission have been reduced by the government for BS6 standards as compared to the BS4 standards. That's why we need to either change the engine or we need to scale down the emissions by using the additives in the fuel, whether that be gasoline or diesel fuel. So additives along with gasoline show reduction in pollutants as well as improvement in engine performance. Hence we can comply BS6 standards with additives without changing the actual engine which we are using right now. So types of additives are bioadditives. Bioadditives consist of bioethanol, turmeric leaf oil, algae oil, etc. And chemical-based additives consist of oxygenates, which consist of propanol, butanol, isopropyl alcohol, etc. And ethers and anti-knock agents. Also, nanoparticles comes under additives. For doing the combustion, emission, and performance analysis of petrol engine, this is the experimental setup used by various researchers. There is an engine connected to the eddy current dynamometer, which is responsible for the measuring the torque and RPM. Loading unit is responsible for loading the engine. Then exhaust is connected to the exhaust gas analyzer, that can be a 5-gas analyzer that is responsible for measuring carbon monoxide, carbon dioxide, then hydrocarbon, NOx emission, and oxygen emissions. Also, smoke meter is connected in case of diesel engines, as opacity is more in diesel engines. But as I am mainly focusing on gasoline engines, so smoke meter is not required. Then data acquisition system is responsible for collecting all the parameters, performance parameters, and feeding it to the computer system, and we can get the output on computer system. This is the literature review that I have done. I have referred around 21 papers. Due to time constraint, I will not explain that. I will directly come to concluding remarks. For alcohols, I found that alcohols like methanol, ethanol, propanol, and butanol reduce emissions of HC and CO, means hydrocarbons and carbon monoxide, whereas they increase the emissions of carbon dioxide and nitrous oxide. As the temperature increases, NOx emissions will be increased. In most of the cases, the performance parameters like brake thermal efficiency are slightly reduced, as the calorific value for alcohols is less as compared to the gasoline. So the brake thermal efficiency will decrease. Methanol and ethanol blended with gasoline allowed to achieve higher compression ratio without knocking phenomena. So it can be beneficial in that way also. Now coming to the algae oil is not desirable additive as it increases the emissions of NOx as well as carbon monoxide compared to the neat gasoline. Also it increases the fuel consumption and reduces thermal efficiency. So it's not helping in any way. So algae oil is not a desirable additive. Now coming to the next additive, that is acetylene. If acetylene is added to the lean mixtures, then it increases the brake thermal efficiency and reduces carbon monoxide emissions. Also, acetylene addition reduces unburnt hydrocarbons and increases NOx emission. Solketal with the blending Solketal gasoline fuel, octane number and brake specific fuel consumption increases. So brake specific fuel consumption increase is not desirable. Also the carbon dioxide and NOx emissions were hiked with the use of Solketal blends as compared to the neat gasoline. Hence, Solketal can be used as octane number improver, octane booster, but it cannot be used as an additive. Now coming to the ethers. First of all, ethers are carcinogenic, so they are not desirable additives from the health point of view. By addition of dimethyl ether, fuel consumption can be reduced marginally. HC and NOx emissions were reduced and CO emissions were increased. For diisopropyl ether gasoline blends, thermal efficiency was improved. CO and HC emissions were lowered as compared to the neat gasoline. Now coming to the fusel oil gasoline blend increased engine power, CO2, HC emissions and NOx emissions were reduced as compared to the neat gasoline. So the recommendations. Researchers have discussed various factors to be considered for additive or alternative fuel selection. Performance should not degrade with the use of additive as compared to the gasoline. So the performance parameters mostly can be same or can be hiked with the use of additive, but they should not be decreased. Additives should have similar properties as that of gasoline engines, so that we don't need to make changes in the existing engines. Otherwise the cost of engines will be very high. Environmental effects should be considered. Additives should not contaminate the environment and should not be harmful for human health. Cost of additives should be taken into consideration as it is a big parameter. Then availability and accessibility of additive is also an important parameter to be considered. Then alcohols production on large scale is possible and are widely used today for blending in gasoline. Bioethanol is the best option among all the alcohols as it is a renewable fuel. Bioadditives like turmeric leaf oil, that is curcuma longa L oil, should be deeply studied as it is produced from agricultural waste of turmeric leaves and it is not being given importance. As I have studied the literature, I didn't find single research paper in Scopus Index or SAI Index journal regarding the turmeric leaf oil. So here in this field only I will be doing my MTech dissertation work regarding the turmeric leaf oil. Economic study for bioadditives. If the countries begin to blend bioadditive in gasoline, they can save up to at least 10% of gasoline and expenditure also. In India, from 2018, 10% blending of ethanol is allowed in petrol. So we can save 10% of gasoline by using ethanol or other additive. Also by using bioadditives like ethanol, turmeric leaf oil, they help to boost local economy. Then also they improve the condition of farmers as we are buying the waste products from agricultural land. By selling turmeric leaves, the income of farmers will increase and it will improve the economic condition of farmers. So conclusions. Additives can be used in engine without modification. The emission using additives can be satisfactorily reduced and performance parameters are improved in most of the additives. Also, bioadditives like ethanol and turmeric leaf oil should be used instead of chemical additives as in consideration of the health point of view. And also, bioadditives can be beneficial in improving the local economic conditions. Thank you.
it's a good presentation. But then turmeric leaves, you have to extract turmeric oil, right?
Yes, sir.
So that also becomes quite expensive.
No, sir. If we do it on a large scale, then it can means.
Where can you have that much of feedstock material to produce a lot of
No, sir.
volume of?
In our Maharashtra region, in Kolhapur, Sangli region, there is a lot of plantation of turmeric, and turmeric leaves are wasted. So we can make use of that.
Okay, thank you.
Okay, thank you.
With this, we are conclude our paper presentation session for today. So I would like to invite all the participants to come forward so we can have a group photo, please. All the participants, please.